In today's session, we are going to see whether the given function y is equals to f of x is a solution of the given differential equation or not. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. The question is, verify the given function is a solution of the corresponding differential equation. The function over here is y is equals to e power of x plus 1 and the differential equation is y double dash minus y dash is equals to 0. We need to verify that this given function is a solution of this given differential equation. So if you try to observe over here the given differential equation, y dash is a first order derivative and y double dash is a second order derivative. Let us try to get the first order derivative and the second order derivative from this given function. We will try to differentiate this y with respect to x once and twice to get y dash and y double dash. So we have the function y is equals to e power of x plus 1. Let us try to differentiate y with respect to x. So derivative of y with respect to x will be dy by dx is equals to, so differentiation of e power of x will be e power of x itself plus derivative of the constant 1 will be 0. So therefore we have got dy by dx to be equals to e power of x. Dy by dx can be written as y dash. So we have got the first value y dash. Let us even get y double dash. So for that we need to again differentiate this one. Differentiate with respect to x. So derivative of dy by dx is d square y by dx square. It should be equals to. So differentiation of e power of x will be e power of x itself. D square y by dx square can be written as y double dash. So let us try to substitute this y dash and y double dash in the given differential equation. So we will take the left hand side of the given differential equation and prove that it is equals to 0 to verify. So consider the LHS value y double dash minus of y dash. This is nothing but y double dash value is what? E power of x minus y dash value is what? Y dash value is e power of x. So here the positive and negative value will get cancelled and we get the value to be equals to 0. So that is what we wanted to prove, y double dash minus y dash to be equals to 0. So we have got the RHS side. So hence we have verified the differential equation y double dash minus y dash is equals to 0. The next question is y is equals to x square plus 2x plus c and the given differential equation is y dash minus 2x minus 2 is equals to 0. Here we have y dash, the first order derivative, which means I need to differentiate this y with respect to x once. So the given function is y is equals to x square plus 2x plus c. Let us try to differentiate this one. Differentiate with respect to x. So we get dy by dx to be equals to, differentiation of x square will be 2x plus 2 into differentiation of x will be 1. So 2 times of 1 will be 2. Plus c is a constant, differentiation of a constant is 0. Therefore, dy by dx represents y dash, which is nothing but on the right hand side you have 2x plus 2. Now take the given differential equation and substitute this value there. So therefore, we will take the left hand side of the given differential equation, which is y dash minus 2x minus of 2. Let us try to substitute this value of y dash over here. Y dash value is 2x plus 2. and this minus of 2x minus of 2 as it is. We see that this positive and negative value will get cancelled, and this positive and negative value will get cancelled. So we are left out with 0. So hence we have got LHS is equals to RHS. So we wanted to prove this result, y dash minus 2x minus 2 is equals to 0. So hence we have verified it. The next question is y is equals to cos of x plus c, y dash plus sin x is equals to 0. So the given function is y is equals to cos of x plus c. Let us try to differentiate this y with respect to x. So differentiate with respect to x. So derivative of y with respect to x will be dy by dx is equals to cos of x, differentiation of cos of x will be minus sin of x plus constant differentiation will be 0. So dy by dx can be written as y dash. So therefore we have got y dash to be equals to minus sin of x. Now let us take the differential equation. So the LHS of the differential equation is y dash plus sin of x. So just try to substitute this value of y dash. Y dash value is minus sin of x, and this plus sin of x will be as it is. We see that the positive and negative value will get cancelled, and we get the value to be equals to 0. So hence we have verified the given differential equation. LHS is equals to RHS. The next question is y is equals to square root of 1 plus x square, and the given differential equation is y dash is equals to xy by 1 plus x square. So we have to get the first order derivative y dash. So let us try to differentiate this one. So given the function y is equals to root of 1 plus x square. So let us try to differentiate this y with respect to x. So derivative of y with respect to x will be dy by dx and root of x. So if you want to differentiate that one, we know d by dx of root of x. Root of x differentiation will be 1 by 2 root of x. So therefore if I use this formula over here, root differentiation will be 1 by 2 root of this entire value 1 plus x square. So we have differentiated this square root value into, let us try to differentiate the value inside this square root. Derivative of 1, the constant will be 0 plus derivative of this x square will be 2x. So therefore we have, it is 2x divided by 2 times of, it is root of 1 plus x square. So we see that this 2 and 2 will get cancelled. We get the value to be equals to x by root of 1 plus x square. But we see that over here you don't have this square root. So square root is eliminated here. So therefore we need to eliminate this square root. For that we can just try to rationalize the denominator. So it is better we multiply and divide. So I am writing in short, this is multiply and this is divide. Multiply and divide by a root of 1 plus x square. So we get dy by dx to be equals to, so we write x by root of 1 plus x square as it is, multiply it by root of 1 plus x square divided by a root of 1 plus x square. This will be equals to the numerator value as it is, x root of 1 plus x square is divided by, so it is root of 1 plus x square, root of 1 plus x square will be root of 1 plus x square whole square. So we see that this square root and square will cancel out, and in the denominator you are just left out with 1 plus x square. And in the numerator I can write down this x value as it is, this square root of 1 plus x square is nothing but y value. So therefore, you can replace y, since we know that y value is nothing but root of 1 plus x square. So therefore, we have dy by dx to be equals to xy by 1 plus x square. Have you got that result here? So dy by dx is nothing but y dash. So I can replace this dy by dx as y dash. So y dash will be equals to xy by 1 plus x square. Hence, we have verified the differential equation. The next question is y is equals to ax, and the given differential equation is xy dash is equals to y. So this is the given function y is equals to ax. Let us try to differentiate with respect to x. So derivative of y with respect to x will be dy by dx is equals to a as it is. Differentiation of x will be 1. So now this dy by dx can be replaced by y dash, and this a into 1 will be a. Let us consider the left hand side of this differential equation. We have LHS is equals to xy dash, which is nothing but x into y dash value is a. So x into a or a into x, anyway you write it. So can I write this as ax? But what is the value of ax? Ax value is nothing but your value of y. Ax is y. Therefore, we will try to replace that by y. So is that the RHS y value, right? So therefore, we have got the RHS value. Hence, we have verified the differential equation. So the next question is y is equals to x sin x, and the given differential equation is xy dash is equals to y plus x root of x square minus of y square. So let us take the function y is equals to x into sine of x. So let us try to differentiate this one with respect to x. Differentiate with respect to x. If you want to differentiate this one, this x into sine x is in the form of a product. So we have to use the product rule. So this will be your u value and this will be your v value. And we know the product rule as d by dx of u into v. First function as it is, differentiation of the second function, plus the second function v as it is, differentiation of the first function u. So let's try to use this product rule over here. Differentiation of y with respect to x will be dy by dx is equals to u, that is x as it is. Differentiation of v, differentiation of sin x will be cos of x, plus v as it is, that is sin x as it is. Then differentiation of u, differentiation of x with respect to x will be 1. So we get the value to be equals to this x cos of x plus sin of x into 1 will be sin of x itself. So this dy by dx can be written as y dash. Now we need to verify this given differential equation. If you try to observe over here, on the right hand side, getting this square root of x square minus y square using the left hand side is a bit difficult. So we'll try to find the left hand side separate, we'll try to find out the right hand side value separate, and then we'll try to verify LHS and RHS. Now we'll start with the LHS value. LHS value is what? xy dash, which is nothing but x into y dash value we have got it, which is nothing but x cos of x plus we have sine of x. Multiply this x inside, x into x will become x square cos of x, plus multiply this x inside, we have x sine of x. So left hand side has been obtained. Now let us go for the right hand side, RHS value. So what is the RHS value we have? It is xy dash is equals to y plus x into root of x square minus y square. Y plus x into root of x square minus y square. So I'll retain x value as it is and substitute the value of y to be equals to x sin x. So in place of y, let us put it as x sin x. So here y value is what? Y value is x sin of x plus x into, it is root of x square as it is. Y value is x sin of x whole square. This is nothing but x sin of x plus x square root of x square minus. This becomes x square and sine is also squared. We will be getting sine square of x. This will be equals to x sine of x plus x into square root of. So what is common over here? X square is common, right? So x square is taken common outside. We are left out with 1 minus sine square of x. So this term as it is, x term as it is, root of x square. What is 1 minus sine square of x? 1 minus sine square of x will be cos square of x. Writing this value as it is, square root of x square will be x only. The square and roots will cancel out. We'll just be getting x into cos of x. So root of x square is x and root of cos square of x is cos x. So this is nothing but x into sine of x plus multiply x into x will become x square cos of x. So we'll just try to check left hand side LHS. So it is x square cos of x. If you want to rewrite, you can rewrite one more step here. First you write x square cos of x. Next we'll try to write x sine of x. Are these two values the same? X square cos of x plus x sine x. So we have got the LHS and RHS to be the same. So comparing the LHS and RHS, so we see that LHS is equals to RHS. So that's the required solution. So that's all I have for today for this session. If you like my video, please subscribe to my channel. Thank you.